Hello, today is January 31st, 2020. My name is Douglas Huff, and I'm in the Tuesday lab session at 1 p.m. with Alex Sample as my TA. This week I will show you the growth of my crystal. In the first video, I had relatively no growth at all. This was about 2 weeks ago. Even last week around this time, I didn't really have any growth. I had possibly one tiny crystal in the vial. However, that's not really the case this week. This week, I tried to count, and I have about 14 crystals in my vial that vary from size to small to large. I'll try to show you really quick. You can kind of see the crystals. They vary in size from small to large, and the first thing that pops into my mind when I look at them are diamonds. They're pretty transparent, and they're relatively clean cut, similar to diamonds that are put in rings and whatnot. Though they aren't obviously as perfect as diamonds, there are some with impurities and some aren't as clean cut. They're not the same size, and the edges are a little bit more jagged. And obviously they don't have that rainbow effect that real diamonds kind of have. But that's definitely the first thing that pops in my mind when I look at them. There is one that is very large. It's the largest one, and it's definitely the most clean cut in there, and it's very transparent and looks great. Moving on, we're gonna calculate the percent yield in the lab. So in the lab, we used aluminum foil that was 1.007 grams. Using the molar mass of aluminum, which is 26.98 grams per mole, we can divide the amount of aluminum we used by the molar mass to figure out the moles that we used. So dividing that out, so 1.007 grams divided by 26.98 grams per moles gives us 0.037 moles of aluminum used. Now, we also know that the molar ratio of alum to aluminum is 1:1. So theoretically, we should have also produced 0.37 moles of alum, which, using the molar mass of alum, which is 474.39 grams per mole, we can multiply the molar mass and the moles we should have produced to figure out the mass of the alum theoretically produced, which, as you can see here, turns out to be 17.71 grams of alum. Now, calculating the percent yield, the formula for percent yield is the actual yield over the theoretical yield times 100. Our actual yield in lab was 14.485 grams, and we just calculated our theoretical yield, and that was 17.71 grams of alum. So dividing those, so the 14.485 divided by the 17.71 times 100 gives us a percent yield of 81.79%. Obviously, 81.79 does not equal 100. So an explanation for why we didn't get 100% yield could be due to some sort of human error. For example, we could have lost some chunks in the wind while walking back from the scale to the lab bench. Or we could have even lost some in the filtration process, though we were trying to get rid of some impurities in the product. We could have got rid of some with a little bits of product. So this is my update for the week. Adios.